Right now, you are traveling at roughly 800,000 kilometers per hour. You don't feel it. The coffee on your desk doesn't ripple. But our entire solar system is hurtling through the Milky Way. We are passengers on a blind ship. We have mapped the stars and calculated our trajectory, but we have no control over our destination. We are drifting through a cosmic ocean that is profoundly indifferent to our survival. Our sun is in a quiet neighborhood, but the cosmos is filled with unpredictable, lethal threats. If a massive nearby star were to reach the end of its life and collapse, the resulting supernova could strip Earth at its protective atmosphere in an instant. There are invisible monsters out there too, stellar mass black holes, the remnants of dead stars, wandering through the dark. If our solar system drifted too close to one, its gravity could disturb the Oort cloud, sending a barrage of comets straight toward our fragile planet. What if humanity stopped drifting? The physics actually exists to build a megastructure capable of piloting our entire star system across the galaxy like a spaceship. Passive survival relies entirely on cosmic luck. Taking physical control of our star is the only mathematical way to actively steer our solar system away from deadly gravitational fields and guarantee humanity's long-term existence. To understand moving a star, we have to look at the extreme physics of light. Light has no mass, but its photons do carry momentum. When they strike a surface, they exert a tiny physical push, known as radiation pressure. Over a small area, it is practically zero, but over a massive scale, that pressure becomes immense. The sun is a furnace shining with the energy of 1 trillion nuclear bombs every second. If we capture that energy, we can harness its momentum. Enter the Shkadov thruster. It doesn't rely on chemical rockets or science fiction warp drives. It is a gigantic mirror. The solid metal shell would shatter under its own stress. So instead, we would construct a parabolic Dyson swarm out of quadrillions of independent mirror panels. This diagram illustrates how the thruster creates movement. Positioning this colossal mirror swarm over one side reflects solar radiation back. Light escapes the open side, creating asymmetrical thrust. The sun pushes against the mirrors with light, and they pull back with gravity, dragging our solar system forward. With the Shkadov thruster in place, the sun becomes a directed propulsion system, physically pulling us across the galaxy. The scale of this endeavor requires an astronomical amount of raw material. Even if the mirrors are built as lightly as possible, creating a swarm large enough to move a star requires roughly 100 quintillion tons of mass. We would have to literally disassemble an entire planet. Mercury is the best candidate for this. It is the closest planet to the Sun, rich in metals, and has roughly 1/3 of Earth's gravity, making it incredibly efficient to launch material from its surface. We would deploy an army of autonomous machines. Strip miners would tear into the crust, refiners would extract valuable elements, and massive electromagnetic railguns would launch polished mirrors into orbit at high speeds. This chart visualizes the principle of exponential manufacturing. Once the first few mirrors are in orbit, they capture the solar energy needed to power the construction of more. One mirror powers two, two power four, and the swarm builds itself. The math of doubling times is relentless. If our infrastructure on the surface can maintain a steady pace of production, 60 generations of robots would reach the necessary scale to finish the entire swarm in about 10 years. Wielding the power of a star carries severe risks. A structural failure, or a slight error in calculating the orbital angles, could accidentally refocus a beam of concentrated sunlight directly onto Earth. We would be incinerated in seconds by our own creation. We would only take a risk like that because staying still might guarantee our extinction. When we look at the billions of habitable planets in the Milky Way, we observe 0 galactic civilizations. The profound silence suggests a great filter, a barrier that eliminates passive species. But an even larger threat is approaching us. Dark energy is pushing the universe apart at an accelerating rate. This animation illustrates our cosmological horizon. Because space itself is expanding, galaxies beyond a certain distance are moving away from us faster than the speed of light. Every single second, 60,000 stars slip past this horizon, irretrievably out of reach forever. Eventually, all the galaxies outside our local group will cross that line. No information from them will ever reach us again. To a being born in the distant future, the universe will look like a black void containing only our single isolated galaxy. Building a stellar engine means accepting this. We might be able to pilot our star, but we are piloting it through an increasingly empty universe, committing ourselves to the longest, loneliest haul imaginable. By stealing our sun, we move beyond the limitations of our home planet. Ultimately, we would become a species that physically moves the heavens themselves to secure our own distant future.